All right, I think we're live. I'm checking, and it looks like we're probably live. Let me give this just a second. Yeah, all right, there it is. Cool. So, welcome to the stream. I posted on Twitter this morning mentioning I am planning now to turn Thursdays into my JavaScript fundamentals days, and that means that every Thursday I'm going to do a set of tutorials that cover just JavaScript basics. This is in response to a lot of people that I've talked to asking me, hey, how do JavaScript? And I'm like, well, JavaScript do. So this is the response to that. I'm hoping that I can put together some helpful little informational bits that will clear up some of the basics that a lot of people seem to get hung up on when I work with them in JavaScript. So let's kick it off. The first things that we're going to talk about are going to be assignments. So that means, that means var, let, and const. Now, if you aren't familiar with let and const, but you've been programming for a long time, it's entirely plausible. I've met a lot of people with that issue. Let and const are ES6 features. They're new to JavaScript, though they've existed in other languages for a long time. So let's hop right in. Let's talk about var, just your basic assignments. So I'm going to uncomment. I've got a whole set of examples here that I'm going to comment and uncomment to show them off in the code pen console here. So let's see. We've got an error already. What's the issue? Is it... Oh, whoops. I wasn't supposed to uncomment that line. Okay. First thing is just a basic assignment with var. So if you... I guess I should also say, if you're new to JavaScript and you're not familiar with var, which is also plausible, you've only been using let and or const, then var is just how we've done assignments in JavaScript for forever. ES5 and before has always used var. Now, this is a basic assignment for var, right? We just, we make the var declaration, we give it a variable name, we pass it a value. That value can be anything, string, object, array, whatever you want. Then we're logging it out. And we've got the string of foo, which is right. That's what we expect. So that's a basic assignment, as in we're doing the assignment inline when we declare the variable. Now we're going to hop down to a late assignment where we declare the variable early. We declare the variable early on, and then if we log it out, we see undefined. So the variable exists, so it won't throw an error, but there's nothing in it. So it's undefined. Then we're going to make an assignment, so we'll stick a string in there, foo, and then we log it back out. We get our string. Great. That's totally common. Everything makes sense. Let's hop down to the next one. Now this is an out of order assignment. Now things start to get a little weird here, but what's happening is we're logging out foo, which it doesn't look like it's been defined yet at this point, right? Now, down here, we're assigning something to foo, then we log it out, and then we define it. So if we check over here, foo is undefined. Great, that's what we expect on the first one, and the second one, it has a value, okay? But if we copy this down here and say 3, this var foo does not set foo to undefined or anything like that. And what's happening here is called hoisting. So what JavaScript does when you make your assignments is it will take all of your vars, all of your assignments, or all of your declarations, I should say, not your assignments, and move them to the top. So this code, the way that it was, is exactly the same as doing the declaration up here and the assignment down here. So it's the exact same as our last example. Now, what if we do foo, and then bar. So we assign foo to foo, and then we declare foo with a value of bar. Now if we look at it, it does, again, maybe what you expect, maybe not. What I said just a second ago, JavaScript hoists the declarations to the top. So var foo is going to be defined up here, and then foo is going to be assigned the value of bar down here. And this is the exact same thing as what we just had written, because JavaScript takes all of your declarations and moves them to the top of their scope. So let's see. There was one other thing that I wanted to show with this. What was it? Oh, I want to comment that out and see. So we don't actually get anything printing out now. So let's look at the browser console and we'll see that's because foo is not defined, right? So it's not been declared. It does not exist anywhere at all, period. It's just not a thing. And that's because the declaration doesn't exist anywhere. So it's not been hoisted. It's not down at the bottom. It just doesn't exist. But if we uncomment that, then the declaration gets hoisted and everything is, in fact, declared. So hoisting is a giant pain in the rear. It's dumb and stupid and dumb. Actually, that's not true at all. Hoisting saves a lot of people's butts because if you do these declarations later than you expect, JavaScript just magically makes them work. Whereas in a lot of other languages, if you do that, you're just going to get an error. However, just getting an error may actually be preferable. We'll look at the next example here, example 4, where hoisting is the devil, because it is. So let's uncomment this and see what happens. Okay, so we slowly get these 3C console logs. So let's look at what's happening. So we set an array with the items A, B, and C in it, or the strings A, B, and C, and we declare a variable of message. That's empty, but it's defined. And then we run a for loop. This is a basic for loop, which I will go over all of the types of loops in a different video. So if this doesn't make sense to you, sorry, but it will one day. And then inside of the for loop, we're going to say message equals text I. And so that's going to get whatever the current index is from the text array. So if we're on the second iteration of the loop, we'll get B, which will be index 1. And the message will equal that, right? So set timeout, and we're going to console log the index and the message. But hang on a second, because as we're going through this loop, it should be I equals 0, so text 0 would be A. And the first time this log happens, it should log out 1 or 0 and A. But it doesn't. It logs out 3C every single time. This is because of hoisting. So our message is getting set up here, right? And we're changing the value of it, but we're doing a set timeout. This is another thing that I'll cover in another video, but set timeouts basically we'll set a delay. We're just saying the current index times 1,000 milliseconds. So it'll be 0 milliseconds and then 1,000 milliseconds and then 2,000 milliseconds for A, B, and C, or iterations 1, 2, and 3, or 0, 1, and 2. And then when it does the set timeout, it will log out the values of I and message. However, because of hoisting, those values aren't what we expect them to be. So I and message are basically always 3 and C because of the hoisting inside of the set timeout. So this can happen. I mean, right now I'm sort of forcing it with set timeout, but this can happen inside of race conditions and just inside of long blocks of code and all kinds of things where you wouldn't necessarily expect to see a bug like this. And it's not an easy bug to diagnose. So that's all of the examples we have for var. Here's the gist of it. Don't use var anymore. var is an old thing. It works, but it's also got a lot of flaws, like I showed you with the hoisting. So let's talk about the next one. Let's talk about let. So the difference between var and let is that let is block scoped, whereas var is only function scoped. So if you're inside of a function, then and you declare a variable, it won't escape that function, right? And the same with a let. But if you're inside of, for example, a for loop, the var will be defined in the function scope, which is going to go outside of that for loop, because for is a block method. So let's go ahead and run this first one. Again, it's a basic assignment. It's exactly the same as the var example, except we're using let. So yeah, no difference here. Let's move on to the next one, which is an out of order assignment. And what's going to happen here is we'll get nothing, right? So it's another error. Foo is not defined. That's because let does not get hoisted. Like I said earlier, getting an error may be preferable in these situations because hoisting can also lead to bugs that are really hard to diagnose. If you use let, your application won't run. You'll get an error letting you know that the method is not defined when it matters. So here where we're trying to assign a value to foo doesn't exist yet. Down here after we do a let, then it does. If we move this up above here, then everything will be just dandy. Oh, I'm sorry. We're gonna need to move it up above the console log. Yeah, and now foo is undefined, right? So there's out of order foo. Let's look at the next one. Where hoisting doesn't cause an issue when we're using lets. So we're gonna uncomment this, and we'll see our messages come in, A, B, and C, 0, 1, 2, which is what we expect and what we want. And the reason that this all works right is, again, because we're using lets rather than vars. If I use a var, message gets hoisted, the value gets set, and everything goes to pot. But because we're using let, it is block scoped. That means if I try to console.log message outside of the for loop, well, first off, we're going to get an error, right, beforehand, because again, it's not defined. But if I delete that and we come down here and log after the loop, we're getting that error. Message is not defined. Message. Yeah, same thing. Message is not defined. So let can actually fix our issues with hoisting because it doesn't get hoisted. And it's also block scoped, which makes it a whole lot better. So don't ever use var. It's just going to make you sad and miserable, and just don't do it. Using let is the way to go. Now, before I move on, I also want to point out that so CodePen allows you to do preprocessors, right? So I could come in here and set my JavaScript preprocessor to Babel. And what that would do is all these ES6 features would get precompiled, and it would actually use var, but it would scope it so that I don't have to worry about the hoisting and such. However, I'm not using a preprocessor right now. And that is because let and const are supported in most modern browsers. I think in all modern browsers right now. So if you use let and const just in vanilla JavaScript without a preprocessor, you should not have any issues. I think I actually have a library where I've done that, but we'll talk about that another time. The point is, we don't actually need a preprocessor. This stuff runs in the browser, which is really, really cool. Yeah, if you're still working for older browsers, then you should definitely run it through a preprocessor. You should probably run it through a preprocessor anyway, because it'll make your life better. But we'll talk about preprocessors another time. Oh, and the dog really wants my attention. So we'll just close her out. There we go. Sorry, puppy. Okay, now let's talk about const. So I'm going to uncomment our basic assignment for const. Again, this is exactly the same as let or var. We're just using const, and after we log it out, everything is just dandy. It looks all magical. let's pop on down to out of order assignment. Now I'm not going to bother with uncommenting this because this out of order assignment doesn't seem to work on CodePen. What happens is that it'll actually, CodePen will give me an error trying to put the code in. I am not sure what this error is because there's no message that comes along with it, which is super cool. So Chris Coyer, or any other CodePen guys, if you see this, you should look into that and fix it. But the issue here is similar to let. We're defining const after our foo assignment. So our declaration is after our assignment. So we should get the same error as we get with let, but CodePen's not letting us have that. So we're just going to kind of skip over it. In general, out of order assignment, it's going to be the same thing as let. But let's look at our hoisting example with a loop. So this is not what you want to do. This is not something that const is supposed to be used for. But the difference between let and const is that when I assign a value to const, it cannot be changed, or it should not be changed. No, actually, it cannot be changed. And we can tell because we're not getting any more logs out. We just get the first one, and then it stops. And it stops because we're getting this error. And this error, assignment to constant variable, that is talking about this right here. So we're actually trying to increment the value of I, or the index, with the plus plus operator, which basically just says I equals the current value of I plus 1. But that's not working. And that is because we have set a const and we've assigned the value. So changing that value is not something that we're allowed to do. That's why in a lot of Node applications, and I'm going to go ahead and comment all this back out, but in Node applications, you'll often see if they're not using module imports and exports syntax, then you'll see things like const react equals require react. And that's using the Node require syntax for React and setting it as const, so we cannot change it at any point in the future. Cool, so that's the basics of assignments. I'm going to go ahead and just copy this title because we're going to create a new pen to talk about functions. I think I may have overpromised on functions. I don't know if I'm actually going to talk about closures today, but we'll see. We'll see when we get there. So we'll name this guy functions. Cool. We're going to save it. Great. And we're going to turn off our precompiler because, again, we don't need it for the stuff that we're doing here. Okay, so there are two main types of functions that you can run in JavaScript, in modern JavaScript. There's the basic function, which is a block scoped function. And CodePen doesn't like it because there's no name for it, so we're going to say function foo. Well, actually, we should probably talk about naming functions. So this syntax right here is we're saying, hey, we're about to declare a function with this function keyword, and then we name it foo. The parens are our function signatures, so we can say bar, comma, baz, and then whenever we run this function, we can pass in values to bar and baz, or variables to bar and baz. And then this is our execution block. So anything that's in here is what gets run when we do a function. Now, we can do this differently as well. We can actually remove that name and then do something like let foo equal function. And what this is doing is assigning that function to the variable. This is, so there's some weirdness around this that I should probably talk about as far as hoisting again. If I do let foo, then this function will not be hoisted, right? So I can't go at any point and say, let's run the foo function and it works. No, that's not how things go. Rather, if I try to do foo over here, I will get an error. So if I look over here, foo is not defined, right? Great, because we used let. However, if I do function foo and name it foo, it does in fact get hoisted. So we're going to say bar baz, and then we're going to pass in these guys as strings just so that it'll print them out. Great, and there we go. So it's actually running, even running the function of foo, even though that function isn't declared until after we use it. Now, that's because of hoisting. JavaScript likes to make sure that everything that you define is available when you expect it to be available. So they take our function declarations and just jam them up to the top of the page. So if we do it like this instead, let foo equal function foo, foo is not defined anymore, right? Because we've used a let to define it. And then we won't have access to foo until after we've declared the function. And that is a lot better. We should really focus on making sure that it works that way. Now I'm going to go ahead and close that and say, instead of giving it a name over here, we're just going to make it function and then pass it skip straight to the function signature. No, this is called an anonymous function. So this function does not have a name. I could also just do it like this, and we get an error from CodePen because CodePen doesn't like this, but this is not going to execute anything at all, basically. We could also wrap it up like this, and it runs. This is called a closure bar baz. Great, and now it's actually receiving those values. So essentially what we're doing here is extra weird. This will still run because JavaScript is not white space. It does not follow a significant white space rule, which means indentation, spacing usually doesn't matter at all. I mean, there are plenty of instances where it does because, you know, we can't have any simple rules in JavaScript, but the gist of it is this still runs. Anyways, the reason it does that is because it pretends there's no space there at all. There's no new lines. Okay, so we're wrapping it in a closure, which is just a pair of parens, which means that whatever is inside here is going to get returned from the parens. And so we're returning the function, and then we're just calling it. So this is an anonymous function that we're immediately calling. So we can do whatever we want inside of this, and it won't ever be available to anything on the outside, basically. So I can't say, like, you know, what the hell is that function name? Because it doesn't have one. And also because it's contained inside of this closure. So, okay. Anyways, I got a little bit off track there. So we've got basic functions. We'll just do function foo there. And that's our function foo. We also have fat arrow functions or arrow functions. They're actually called fat arrows in CoffeeScript. They're just arrow functions in ES6. So ignore the fat arrow thing that I said. All right. So an arrow function is mostly the same as a regular function, okay? The difference is that inside of function foo, this refers to the function itself. So if we console.log this, oh, we're not calling it, so we'll actually call this with a closure. Oops. Do. Oh, there we go. Okay, there we go. So it's going to return this function, which looks a little weird because it's actually saying it's a window and all this different stuff. That's because it's just in the global context. If I say function foo, and we actually call it like that, then it does pretty much the same thing. We can also, let's see, what do we do? Let's get real weird. All right, function with, okay, anonymous function inside of a closure. Cool. So there's all that stuff. Now it's going to refer to this. So let's say this dot bar equals bar. And if we console log this dot bar, we need to call it. There we go. We get the string bar because this refers to the context. Wait. I'm confusing myself here. Okay. All right. So class syntax is another thing that I'm not going to go deep into right now, but I'm going to use it just to show off this functionality because I absolutely know that it will work this way and I don't have to think really hard to make it work. All right, so we've got a constructor, console.log, this. Okay, it's going to be the object. If we give this a name, we'll just name it blep. And we see blep. Great. So it's class. If we say function let foo equal function, and inside of that function we console.log this. And then we say foo. What do we get? Aha! Undefined. Okay, now we're where I expect it to be. Let's see. Inside foo. Okay, great. So up here we're console logging this, which is the class. But down here we're logging from inside the function. And it's actually returning undefined for this. That's because the function has its own scope, which is isolated from the surrounding scope, which in this case is the class. However, if we use an arrow function, remember an arrow function, not a fat arrow function, then this actually remains the same. So this is scoping, this is the context. This is the context. So in this case, the context is the class. In this case, the context is a class because we used an arrow function. And in this case, the context is nothing because we're inside the function's own scope and it doesn't have anything special in it. So we can actually say this dot bar equals bar. And I think that'll work. Let's see. Nope. Okay, cool. Great. So functions versus arrow functions is a little bit tricky. We're going to rewrite this one as bar with an arrow function. Great. So inside bar. There we go. Now you can see. This one has no context, this one does. So that's the value of an arrow function, is it maintains context. More often than not, you probably want to use an arrow function instead of a regular function. That's because you want to maintain context. Sometimes that's not the case, but usually you do. So let's look at something a little more abstract, like using a set timeout inside of here. So we're just going to copy both of these sections, and we're going to say set timeout console.log. Yeah, and then we'll just say 1 second, which is 1,000 milliseconds is 1 second. So here we are. Okay. All right. So what we actually want to do Here we go. This is what we want. Okay, so the difference here is that now we're actually passing a function to set timeout instead of trying to run console.log directly and set timeout. So if we look at inside foo, we actually see, hang on. Let's do it clear and then rerun this. Okay, foo is not defined. Oh, right. We can actually remove both of these. We'll save and refresh one more time. Okay, so we console log blep, and then a second later, we console log foo and blep. Okay, now, again, we've got different stuff. So the set timeout function is, the context for this is the window, and that's because of set timeout. Set timeout is actually a method on the window object. So if we look at window inside of the DevTools, that's actually like everything here is the window. So we can get information like the location, everything that's in the bar. We can get the document that things are rendering in. We can do all kinds of crazy stuff. But the important thing here is that set timeout is on the window. So if we do set timeout, we'll see it's a function. It's a native function. So inside of set timeout, the context for this is window, right? Now down here, that changes because the arrow function is being executed inside of this constructor. So its context for this is still the class, which makes it real weird. Which makes things real weird. The hard thing here is that if I made another method on here, like do a thing, and inside of do a thing, I want to access a property like this dot foo, right? To just console.log it. And up here, we'll say this dot foo equals foo. Great. Now, instead of passing a function directly to it, I can say, or instead of passing an anonymous function to it, we can say this dot do a thing because it's a class method, and this is the context. So here we go. But when we try to log out this dot foo, there we go. So when we try to log out, let's refresh this so that it runs and it's a little easier to read. Okay, so when we try to log out this .foo the first time, which is in the first set timeout that we passed directly, it's undefined, right? Again, context is the window, and the window does not have this .foo. But over here, we're wrapping it in an anonymous arrow function, which allows it to have the context of the class. I can also use a bind to fix this issue, which would be like this dot do a thing equals this dot do a thing dot bind this. And what bind does is basically every time this function is called from now on, it will have whatever you pass in as the context. So you see it works now, right? So whenever we pass it directly, we have no issues. It's not the window context, it's this, the class context. So that's, call, apply, and bind are also things that I'm going to cover in another video, but hopefully this is clear enough for anybody to understand. Let's see, what else did I say that I would cover in the video description? Let me see. I know I said there were other things. Let's see. Function versus fat arrow. Oh, I need to update that. Anonymous functions and closures. Varlet and const. I guess I talked about it all. Okay, cool. Well, then I'm going to go ahead and call it, because that's shorter than the other videos that I've done so far. So, yeah, all right. Comment, rate, like, subscribe. Tell me what you liked, what you didn't like. Let me know what I can do better. If there's anything that you saw that you didn't like, tell me not to do it anymore. If there's anything you saw that you want to see me do more of, let me know. Or even better, if there are things that I didn't do that you would like to see me do, please let me know, because I am trying to get better at this, and your feedback is very helpful. I will link to, I will flesh this out first, and then I will link to both of these code pens in the video description, if anybody wants to go back and reference them later. In the meantime, I am going to call the stream, and I will see you guys on Tuesday.